Alright, 4.3, number 34. We're supposed to find extrema and where they occur and any points of inflection and sketch a graph. I'm going to start by sketching a graph of this, and that'll, from the graph, we should be able to figure out the other things that were asked. So f is even and it's continuous from -3 to 3. So we're only worried about from -3 to 3. So here's what we know. When x is 0, the function is 2. So 0, 2 exists. 1, 0 exists. 2, -1 exists. So 2, -1 exists. Okay, so the derivative at 0 doesn't exist. Okay, so there's a corner or a cusp or a vertical tangent right there. The derivative at 1 is 0. Okay, so we know we have a horizontal tangent, looks like that. And at 2 it doesn't exist, so a cusp or a corner or vertical at 2. The second derivative at 0 doesn't exist. The second derivative at 1 is 0. So might be an inflection point at that point, and it would make sense that it looks like it's going to go down, be an inflection point, and then go down to here. But let's clarify that. Looking at additional clues, so between 0 and 1, f is positive, so that means it's above the x-axis, which between 0 and 1 it never goes below the x-axis, it just stays up above. Between 1 and 2 it's negative, so from here to here it stays below the x-axis, and between 2 and 3 it stays below the x-axis, it remains negative. F prime, from 0 to 1 it decreases, or it's negative, so the function is decreasing from 0 to 1, which we can see that. It's also decreasing from 1 to 2. 1 to 2 it's decreasing, it's going down because it has to get to that point right there. And between 2 and 3 it's f prime is positive, so it's increasing between 2 and 3. So it's going to go down to this point and then go back up. It's not going to be at 2. The derivative, remember, it doesn't exist at 2, so it's not like it's going to bottom out and go back up. That would make the derivative 0. It doesn't exist, so there's going to be a cusp of some sort or a corner at that point. The second derivative between 0 and 1 is positive, so it's concave up from 0 to 1. Then it's concave down, so it opens down. So it's up, it's down, and then between 2 and 3 the derivative is, the second derivative is negative, so it remains concave down. So we know that it increases at 3. Let's see, it's going to go, remember it stays below the x-axis, so it's going to go like that. So that's the sketch of the right side, everything we know. Let's confirm it. Yeah, 0, 2, 1, 0, 2, -1 are all on there. The derivative doesn't exist at 0. The derivative is 0 at 1, which it is. The derivative doesn't exist at 2, there's a cusp. The second derivative at 0 still doesn't exist. Second derivative at 1 is 0, yeah, there's an inflection point. And at 2 the second derivative doesn't exist either, it's just an endpoint. Between 0 and 1 it is above the x-axis. Between 1 and 2 it is below the x-axis. Between 2 and 3 it is below the x-axis. The derivative, so first derivative is negative from 0 to 1, it decreases, and then it decreases, then it increases. And the second derivative is positive, concave up, concave down, and concave down. Now remember, this is an even function, so it's going to be symmetrical with the y-axis. So we can say Oops, yeah, something like that. And now we can see that the second derivative and first derivative at 0 don't exist. So to answer our question, the first question, find the absolute extrema where they occur, looks like absolute max is equal to 2 at x equals 0. Absolute minimum is equal to -1 at x equals plus or minus 2 at 2, -1, and -2, -1. We are only trying to find the absolute, okay. Points of inflection, we've got an inflection point right here. It goes from concave down to concave up. This is not an inflection point because it goes from concave up to concave up. So inflection points are at -1, 0, and 1, 0. Doesn't change concavity anywhere else.